What's up, guys? Welcome back to the channel. And today we are going to talk about transistors and relays. Have you ever wondered how machines make decisions, turning something on or off all by themselves? From the click of a mechanical relay to the invisible magic of a transistor, today we are diving into the story and the science behind two of the most important components in electronics. Let's get started. Hi everyone. Today in this video we'll explore how relays and transistors work, where they came from, and how you can build simple circuits to understand them. Let's go from the click of a relay to the switch of a transistor. Let's get started. What is a relay? This is a physical example of a relay. A relay is basically an electrically controlled switch. When you send current to a coil inside it, it creates a magnetic field and click. It moves a mechanical contact, turning another circuit on or off. Let's see in action. Do you hear the click? Here's a simple demo I have created. This switch to the coil of the relay. When I press it, the relay turns on the motor. It's like a middleman controlling a high power circuit using a low power one. See? Can you hear it? Right. Relays were actually the brains of early computers like the Harvard Mark I. But as technology advanced, something smaller, faster, and quieter was needed. That's when transistors came into play. Here you can see a variety of transistors on the table. And here's how it works. A transistor has three legs: base, collector, and emitter. If you send a small current into the base, it allows a bigger current to flow from the collector to emitter. It's like an opening valve. Now let's build a simple circuit using a transistor. I am going to use this BZ547 transistor for this. BZ547 is a widely used NPN transistor. The first pin is the collector, the middle pin is the base, and the third pin is the emitter. You can connect transistors to the breadboard like this. Now I'm going to connect few other components to complete the circuit. Here you can see a completed circuit. Now I am going to turn the LED on by pressing on the switch. Here you can see the LED lights up when I press the switch. And also you can see I have two power supplies. One is for the LED and one is for turning on the transistor and turning it off. When you disconnect the power, the transistor lets no current through its collector and emitter. Now let's connect the motor. Now here you can see I have connected the motor. Let's see if it turns on when I press the button. Right. So Let's compare both of these devices. A relay is a mechanical switch, while the transistor is an electronic switch. In speed, the relay is very slow. It can be calculated in milliseconds. But in the other hand, the transistor is very fast. It, its speed can be calculated through nanoseconds. Let in voltage isolation, relay is very good at voltage isolation, but a transistor is not. In noise, uh, the relay makes a clicking sound, but transistor is silent. In size, a relay is larger than a transistor. It's very small. In current capacity, a relay has a higher current capacity, while a transistor has a lower current capacity. But it depends on the transistor package. Each has its place. Relays are great for switching high voltages. Transistors are perfect for small, fast, and efficient circuits. But relays are still used in car electronics, industrial machines, and home appliances. Transistors, well, your phone probably has billions of them inside. From the big clicking relays of the past to the microscopic transistors in our devices today, these tiny components run our modern world, and now you understand the difference. If you learned something new today, give this video a like and subscribe for more awesome electronics content. Let me know in the comments what you want to learn next. Until then, happy tinkering. Bye bye.